Okay, fertilization. So first of all, you have to be very confident in the structure of female genital tract. So we discussed, you know it even from school, but let's make a little reminder. So this is an ovary which is attached and to the uterus and to the with the ligament. So 1 second. Sorry. Yeah. So we're looking at the suspensory ligament of the ovary. So and it is appeared very closely to the fallopian tube, infundibulum and fallopian tube. So this is fallopian tube, which joins the ovary to the womb. And here we used to have a question. So what is the why we need this long tube to connect the ovary to the uterus? So isn't it easier to directly cause the formation of ovum inside the ovum inside the womb? But actually, so it has some reasons, and later I'll explain why. So this is opening fallopian tube, and it grabbing the this side of ovary. So as I explained in last lecture, so directly on the level of the Graafian follicle. So here a Graafian follicle will form, very large Graafian follicle, so and it's grabbed by fallopian tube, and then ejection of the ovum happening into the fallopian tube. So I'll remind you, so that it's a cell which is injected inside. It is a secondary oocyte. It's not ovum itself, so as we used to think. It's a secondary oocyte which haven't completed their second meiotic division. Okay, and the fimbria, which is present here, So finally, so ampulla of fallopian tube number 4 here. Why 5? Yeah, this is ampulla of fallopian tube where fertilization takes place. And finally, we have a uterus. Uterus is a muscular organ, so it's uterine musculature. Number 6. Number 7, it's endometrium. So endometrium, it's a inner lining, so which is soft, gentle, and with nutritional properties for the embryo and fertility to the fetus. And actually here it is attached, a placenta is attached, which supply the fetus during the pregnancy. Okay, and then we have number 8. It is in cervical canal, and here is a cervix opening here, which is opening. Which opening into vagina, and this is vagina. Okay. Also we have Graafian follicle, also sometimes named as a dominant follicle. So dominant follicle, so which suppressed the activity of other follicles and producing finally what we name as ovum, but actually it's a secondary oocyte surrounded by granulosa cells. And during the rupturing of this Graafian follicle, it ruptured directly into the infundibulum of fallopian tube and detached this portion. Okay. This details, and that's how it happens. So when Graafian follicle is formed, so it secretes some special chemicals which chemotactically attracts the fallopian tube, fimbria of fallopian tube, to this, and they like overwhelming it. So like it's shown on the picture, overwhelming it, and all the components of the tertiary follicle or Graafian follicle will enter inside the ampulla of fallopian tube. So that's and this liquid which were collected in antrum of the follicle, it's used for flashing of this ovum into the deeper into the fallopian tube. That's what is going on. Again, you remember there's different stages of follicles. So the secondary follicle, and then final tertiary follicle, and liquid which is happening, which is present in antrum. It helps to fuse, to enter it into the fallopian tube. Okay. So what is a and this is structure which were cumulus oophorus. So but later we name it as ovum. We actually this structure we name as ovum. And I want to mention you this thing. So this is metaphase plate. It is metaphase plate, so where it is ready for second meiotic division, but it is interrupted, and it's finished only after fertilization. So only fertilization will complete this cell division, but before fertilization, it remains in this stage, and in every cycle, actually they are not ovum, but the secondary oocyte, if it's not if it is not fertilized. Okay, and I have to remind you that around the secondary oocyte and first polar body, which is present here, around this we have a zona pellucida. This zona pellucida is sorry. Zona pellucida is a structure which present with the hyaluronic acid, which is hardened structure, so by density it resembling the cartilage, so which when sperm cells get in closer, so they have to penetrate this barrier. So without this barrier, it will be tough. And we discussed it in the previous lecture also. Yeah, so how formation of zona pellucida happens and what the function of the zona pellucida at that time. And around, don't forget about the cells which are named as corona radiata. Corona radiata are follicular cells which are responsible for synthesis of progesterone, and actually it chemotactically attracts sperm cells to its side. Now they keep producing progesterone. It's corpus luteum cells, and that's why this corona radiata play a role of attractors for the sperm cells. So not a barrier, but it's attractor. Yeah, that's what. But gradually the cells are shedding out. They form the scattered groups of cumulus cells. So and they of course inevitably die. So okay, finally let's talk about spermatozoa maturation steps. So how maturation of spermatozoa happens, we a little bit discussed. It's again spermatocytogenesis and spermiogenesis. But actually spermiogenesis is not the final maturation. So and we see that so it has further maturation steps. It's when sperm cells are stored in epididymis, it will the final maturation takes place. So just for instance, I have to say that in epididymis we have stereocilia, so which suck out all the excessive cytoplasm and making the cells are more active. Then after ejaculation, sperm enters into the vagina, and in vagina so activation of the sperm cells takes place, and as well in progression, this process of activation continues with a process known as capacitation. So what is capacitation? We also discussed a little later. And near the oocyte, it performs the acrosome reaction. Let's see it. So okay, ejaculation process. Let's talk about ejaculation process. Okay, in a testis, remember the seminiferous tubules. Then all the seminiferous tubules where primary maturation of sperm cells takes place, they enter into the 1A known as rete testis or efferent ductals of the testis. Sometimes it's named as a vas efferent. So and it drains the sperm cells, mature sperm cells, into the epididymis. So where it's stored for some time. And then this epididymis continues with the vessel known as a vas deferent. And vas deferent, so here it's not shown, but in number 3 it's vas deferent deferens, so it drains the sperm cells finally into the prostate, where it joins, actually outpoaching all this vas deferens, we have a seminal vesicles. So seminal vesicles which produce the very large amount of fluid of the semen. So and also here is the prostate. Prostate gland, it plays a role also of secretory gland, which producing liquid material with the nutrition components inside. So and also producing the digestive products for the sperm cells. and also it's a muscular organ which facilitates the process of ejaculation. And these ducts are opening inside the prostatic part of urethra. And don't forget about this number 9, which is named as bulba urethral gland, also known as a Cooper gland. This is Cooper gland. Our main function of them is the formation of the one of the function of it is the formation of lubrication for the sperm cells, because sperm semen it is very expensive product, yeah, and during the ejaculation we can spend even few milliliters of the sperm just for to keep it inside the urethra. So that's why we need to moisturize it. We need to make it squeezy, that all the sperm cells with the semen will ejaculate, but this squeezy material will remain inside the urethra. Of course, some sperm will remain here, so but it's minimalized. Okay, spermatozoa. And so we discussed in the last class again, head with acrosome on the tip, on the peak of it. On the peak of it, and then we have a nucleus, and inside we have distal and proximal centrioles. So this distal centriole also is forming the tail. So here, after this centriole, we have a midpiece, so which contain mitochondria inside, which given the energy to the tail for motility. And till this D portion of the sperm, it's active portion, actually C plus D portion, it's active, so motile part, but E portion is just present in the end for direction of the sperm movement. So cervical canal. Cervical canal, so it's not always similar during the process of menstrual cycle. In a process of menstrual cycle, before the ovulation, so cervical canal is stuck with a very thick fluid. So this thick fluid won't allow any bacteria. So that's you should understand. We can't keep open organ. So because bacteria enter there and cause acute or chronic inflammation later. That's why we need to protect it. And it is open only under the influence of progesterone and estrogen and progesterone. So that's that allows sperm to enter. But still it's creating the cervical barrier. So that's why males has to produce a lot of sperm cells to penetrate it. So normally cervical canal contains slightly alkaline media. If it by some pathological process vagina or cervix getting more acidic, so a lot of sperm cells are dying. So that's why inflammations of these regions might cause the infertility. So that is functional fertility. Yeah. Okay. And that's how it looks like. If it's dense, so this dense cervix canal before ovulation, so sperm cells are not penetrating this. But in case of ovulation, during the ovulation, so it getting loose, and a lot of sperm cells can enter inside. But not all. Approximately 10% of sperms can penetrate this barrier. But others are dying, so in vagina, or they dying before entering to the cervix, or inside this known as crypts of cervix. So they dying, and then only few cells, relatively few cells, sperm cells, enter into the womb. Okay, so then this lecture is available, so you can read about it also. So, and finally starting the process of known as a capacitation. Capacitation, we can say it's like a functional and a final maturation of the spermatozoon. So you have to be in charge. So that sperm cell, which is kept in epididymis, which is kept in vas deferens, in seminal vesicles, in prostate, it shouldn't be activated as well it enters into the vagina. It shouldn't be activated even inside the male genital tract, because energy which can be used by mitochondria is restricted, yeah, and we shouldn't activate it before it's really necessary. That's why final activation of sperm cells going on in uterus and the cervix and uterus. So, and this swinging movements are activated. Before it, mitochondria are silenced and they don't spend their energy. That's why capacitation is the final activation of the sperm cell. And in some books you can find that capacitation is a process of shedding out of the upper side of the acrosome. So with the which is prepared for acrosome reaction. It will be also part of truth. Okay. Penetration is the cumulus cell, so that's one of the challenge of the sperm when it's finally entered into the womb and then distributed to the right or left fallopian tube. So we have a challenge to penetrate the cumulus cells, but actually cumulus cells are so I said they are easily shedding out. They are not very tightly connected to each other, and that's why sperm cells can easily penetrate through them and reach in the zona pellucida. But finally, when sperm cell enter to the pellucid zone, so on the surface we have on the surface of acrosome we have ZP3 receptors. So this ZP3 receptors, and on pellucid zone we have ZP3. It's known as zona protein 3, zona pellucida protein 3. So and when they get in contact, it activates the acrosome reaction. So what is an acrosome reaction? So I remind you, acrosome it's a sac-like cavity which is filled with enzymes, acrosomal enzymes. They are proteolytic enzymes which are made up of enzymes which definitely destroying zona pellucida. So we need to drill it out. Yeah, so we need to penetrate the sperm inside the zona pellucida. That's the main function of this acrosome. So and when they get in contact with zona pellucida, so this part of the cytoplasm is dissolving, and all the acrosomal enzymes drilling the ovum, zona pellucida, and finally we have a chance for the head of the sperm to enter inside the cavity surrounded by zona pellucida. So, and what happened to spermatozoon? Yeah, so then outer membrane is destroyed, but fragmented. Yeah, and this inner membrane of the acrosome, so actually covering the head of sperm cell. Sorry, some message here. Okay. So. Okay, and finally, so cell surface is destroying. Cell surface destroying, and then head totally penetrate into the into the space between cell, secondary oocyte, and zona pellucida. Okay, let's move forward. So penetration of pellucid zone happening. So, and we have a docking mechanism of the spermatozoon onto the oocyte reaction. So that's docking means it's a total fitting of enzyme, of protein with the protein receptor. So and it docks, and then it has a opportunity to insert inside. So okay, so that's how it's visible here. So when sperm already penetrates the zona pellucida, number 4 zona pellucida, yeah, pellucid zone, then sperm enters inside, and this head is getting in very close contact with the oolemma. It's a cell membrane of oocyte, secondary oocyte, and they docks to each other and causing the fusion of the sperm with the cell membrane here. But okay, about this a little later. So here on the surface of oocyte we have a special sacs present with enzymes. So which enzymes we discuss a little later. It's a little secret. So then sperm invaginate inside. So then nucleus appeared inside, and centriole, this distal and proximal centrioles appeared inside. Mitochondria. So here shown that mitochondria also enter inside, but these mitochondrions are dying. They're just dying, and they play no role in further development of the embryo. Yeah, but these vesicles which are which secreting outside when sperm get in contact, they are responsible for the process known as a polyspermy block. So now let's talk about the polyspermy block. So polyspermy block, it's a process of which prevent the multiple sperms enter into the ovum by which mechanism. So these enzymes which are present inside, they actually destroying the ZP3 receptors on the surface. This they contain enzymes. And we have no ZP3 proteins on surface. Then acrosomes are not more reacting with the ZP3. Then sperm cannot activate their acrosomal reaction. It's the first thing to do. Secondly, they hardening this collagenous masses around the sperm, around the ovum, and make this zone placida very, very, very solid, and then nothing can penetrate it anymore. That's why we need only one sperm. Yeah, if suddenly some polyspermy happens, when 2 or 3 or even more sperm cells entered inside the ovum, so we have a cell which is unable to leave. And so it's and a weak mechanism of polyspermy block. It is a reason for different pathologies, including infertility. Okay. So how impregnation takes place? Okay, again, sperm cell enter inside. Centrosome of the spermatozoon also enters inside. Tail, kinocilium, which is named, so the tail, so that's also will be dissolved very soon. And cytoplasm of previous sperm cell, cytoplasm of head and tail. So it is just fusing with the oolemma, with the membrane of the secondary oocyte. And this entering of this centrosome actually activate the process known as termination of the second meiosis of the oocyte. I remind you, so before it we had meiosis 2, yeah. So this meiosis 2 on the phase of metaphase. Metaphase 2 is in progress here, and absence of the second centrosome, so will not allow the finishing of this meiotic division. But now second centrosome is present, and then it can finish it. So, and we see the situation, the centrosome finishing the metaphase here, and decondensation of the sperm cell genetic material taking place. Decondensation, then it was very, as I said in previous lecture, so it was very condensed genetic material in a sperm cell, and it's decondensing and unrolling the genetic material there, and then finally collecting it back in a frame of chromosomes. Now it was very dense chromatin, yeah, but we need to decondense it to form chromosomes. And now when male chromosomes are formed, female chromosomes are already finished its division, so form the second polar body. You see, second polar body is formed. It's second polar body formed, and this chromosomes, males and females chromosomes, finally forming two pronucleuses. It's like nucleus, two different nucleuses, but they are incomplete. They're incomplete, so they're just preparing for the further mitotic division. It's the first mitotic division of the cell, which is known as zygote. So you see, 4 hours after impregnation, pronucleus has formed, and finally these two pronucleuses dissolve their membranes. So like in prophase 1, like in prophase of mitotic division. So they dissolving, and then these chromosomes arranged in a spindle. So, and we have a pair of each of the chromosome, and then form the first mitotic division. Look at this, guys. Yeah, there are sperm cells which still wanted to penetrate the zona pellucida. They still has a hope that they will fertilize the ovum. But sorry, actually here spindle has formed, and first even mitotic division already happening here. Okay, and furtherly, on this this part of lecture is finished, so we shift to other lecture, which is known as early embryogenesis. And as I said before, so this first mitosis, it is an first mitosis happened directly after the fusion of male and female gametes. So, and this process, the process which causes the formation of two cells, they are named as blastomeres, and it takes place again. So according to the data, you have to understand it happened inside the fallopian tube, and zona pellucida still remained. That's what I want to point it out many times. Zona pellucida still remained, and it restricts the growth of the cells. Division is not followed with the growth of the cells, and it serves to few functions. First of all, it prevents the enlargement of this embryo inside the narrow fallopian tube, and if the zona pellucida suddenly ruptures, so this embryo attached to the fallopian tube, and we have a pathology which is named as ectopic pregnancy, because these cells are designed to attach to the surface epithelia. Okay, but normally it does not happen, and then it moves toward the uterus. This movement towards the uterus, it takes plenty of time, so 7 days, approx. So actually 5 to 6 days, but okay, just for instance, approximately 1 week. And what happening? So so how motion of this goes? Primary movement happened with the help of ovulation, yeah, with the help of antrum fluid. So it it pushes this embryo, nowadays it's embryo, into the ampulla of fallopian tube. But after this, motion is regulated by the process of peristalsis of the fallopian tube, and gradually peristalsis maintained by the estrogen and progesterone. So it pushes this very gradually push this embryo towards the uterus. And what's happening during this journey? During this journey, so embryo, so it from the zygote stage, it divides into the 2-cell embryo stage. 2 blastomeres are formed. Then equal division of the cells happening and form the 4-cell embryo, then 8-cell embryo, then 16 to 32 cell embryo. When it's more than 30 cells of embryo, so which are named as blastomere, which is appeared in 3 days, we name the stage as morula. Surrounded by zona pellucida. Again, I remind you, zona pellucida is still present, and size of the zygote and size of morula is equal to each other. Mass of them are equal. So blastocyst injury. Okay, doesn't matter. So blastocyst. So and later form the blastocyst. So what is how this actually happening? In practical class, it has to be shown, of course. But just for instance, I have to show it to you. In morula, we have an inner cell mass population and outer cell mass population, and before in these stages, you see division is equal. So we have 8 absolutely similar cells, 16 similar cells, 32 similar cells. But after this stage, we don't have the equal division. Now division gets unequal because appear 2 different cell populations. Outer cell population and inner cell population. outer cell population, it will form the structure which is known as a trophoblast, and inner cell population, or inner cell mass, also known as a embryoblast, which is shown here. And this embryoblast plus trophoblast, they produce in some liquid, so just
Lecture
waste
is not.
material. Sorry?
Lecture is not. Lecture is not visible.
Ah, okay.
You're not sharing.
Screen is not available, sir.
Okay, thanks, you mentioned it. Okay, now it's visible?
Yes, sir.
Okay. So what happened? So okay, I didn't get it. Okay. Anyway, so now again, so this is blastocyst, trophoblast cells, and this is embryoblast cell. Actually, it also explaining what is the future role of them. Tropho means feeding, yeah. So trophoblast means feeding cells. In future, they will form the placenta, so which will feed the baby. And inside embryoblast, it is future embryo itself. So it's a future baby, yeah, future child. So that's embryoblast. So that's why this outer cell mass, outer cell population, they are not reliable for the further living. Okay, but still playing very important role in our life progression. Again, remind you, zona pellucida still remains. And then happen in the process, which is named as hatching. So same as an egg hatching. So what is going on? Actually, inside the so when hatching happening approximately on the 5th, 6th day of embryogenesis, when they entered into the womb. And into the womb, so actually produced a lot of compounds, a lot of nutrients, which are nutrients which absorbed through the semi-permeable structure of zona pellucida, and we have a process of gaining of mass of embryo, and this zona pellucida, which is hardened, so it can't bear this pressure from inside, and it hatches, destroys, and embryo finally reaching the uterus. So now it's free. And I already said to you what happened to the tissue, what happened to the trophoblast, when it finds any endometrial cells. They fix into this. So they have a very active sticking properties. It sticks to the surface of the womb, and so here it's shown, and form the and finally forming the implantation site. Okay, embryo has its own polarity. Of course, we have embryonic and abembryonic poles. This embryonic pole, this abembryonic pole. So here we have no embryo; it's just trophoblasts. And this is inner cell mass, so it's future embryoblast, so which is polar. And then implantation, process of implantation is managed by the embryonic pole. So when embryo is present, yeah, and from this side it delves a little deeper. So in female genital system histology and physiology, you will discuss the cyclic changes in endometrium, so which predispose the process of implantation. But you should just in general you should understand that, yeah. So this time period from the fertilization, which is present in ampulla, and migration to the womb. So we have a preparatory reactions in our body. So what is and preparing the very soft bed for this embryo. So it happens under the control of progesterone. This progesterone hormone, which is produced by remnants of how it's called of Graafian follicle. So cells of granulosa cells of Graafian follicle, they are converting to the luteal cells, which produce progesterone, and this progesterone under the progesterone womb is prepared for the entering of the embryo. So now, and hatching happens again also here on the level of blastocyst. So just remind you, zygote, 2-cell stage, 4-cell stage, 8-cell stage, 16-cell stage, also named as a morula. And after this, so after a few more divisions here, we have a formation of 2-cell populations, surrounded by zona pellucida, which is named blastocyst, early blastocyst, and then it hatches and forms the late blastocyst. And late blastocyst is attaching to the surface of endometrium, inner part of the uterine cavity. And then this implantation begins between 6th and 7th day. So which sites of implantation are used? It's usually happens, of course, it happens in uterine body. So and usually left or right side of the of the corpus of luteum. It's very rarely attached to the bottom. It's very rarely attached near the cervical canal. So normally it's shouldn't be here. And abnormally, so it might implantate, as we discussed, in a fallopian tube, and also might be abnormally implanted into the cervical canal. And we name these conditions, abnormal conditions, as the ectopic pregnancy. Ectopic pregnancy. It requires surgical correction, of course. Okay. And this is, but actually, if it's attached to the bottom or left or right side, anterior or posterior, it doesn't matter actually. More commonly, it's posterior lateral side, more commonly, but it might present everywhere. So, and what happening here? So then, endometrium on this stage is composed of 2 layers. It's stratum basale and stratum functionale. So these 2 layers, A and B, stratum basale and stratum functionale. So this in stratum functionale actually is the site where implantation is normal. Stratum basale is where embryo shouldn't reach. So because if it's reaching this place, so it will cause a very severe bleeding afterward. So during the delivery. So normally it's attached only to the stratum functionale. And function of this endometrium is, of course, formation of uterine glands and supplement with the blood vessels. Here we have a special spiral arteries. So in functional zone we have spiral arteries which will feed the baby, which will feed the embryo, and glands which also give the energy to the baby. So, okay. Later I will send you the video about early embryogenesis, so not made by me, so that's why I don't claim it's my video. So, but it has very good graphics. So, so which are showing it much better than in a lecture. So might be in the if you have time till the end of this lecture, I will show it to you. So, yeah, we have. And then when embryo entering inside. So yeah, that's endometrium in middle secretory phase. So when secretory phase is very active, so in this stage, embryo enters inside. You see, it's very thick, thick endometrium, and embryo behaving like a parasite. Embryo just entering inside and eating everything what is here. It ingests all the secretions of the uterus. Also blood vessels which are present inside, so they implement them into their structure. How we going to discuss a little later, but still it uses it for its further growth. So implantation. So here I said about this implantation sites. What is going on during the implantation? So you see in this site, it's embryonic site of trophoblast. It attached to the surface of endometrial cells, and here we also have another hatching mechanism. So the cells are like chain lock, attached to each other and activate each other. So this trophoblast is activated and activates a special type of mitotic division. So where cell nucleuses are dividing, but cytoplasm are not dividing. So and they form in the syncytial cells. Syncytial cells. Syncytial means a lot of nucleuses in a frame of one cytoplasm. It's syncytial cells. and that's why now we have division into the syncytial trophoblast, so which is one cell actually, and cytotrophoblast. But I have to mention again, so that's the same cell population, but just differentiated. It's a differentiation that takes place. And the syncytial trophoblast, it has the properties of invading properties. It can produces a lot of proteolytic enzymes. It produces a lot of cytoplasm. So and it invade the endometrium. And the main task of this is implant the embryo into the thickness of the wall, into the thickness of the uterus wall. And the cytotrophoblast is the source for the further syncytial trophoblast formation. Inside, don't forget what is happening inside. Inside, embryoblast is dividing. Those cells which are present close to the blastocyst cavity, they are forming the hypoblast. So here, hypoblast. And those cells which are present between hypoblast and cytotrophoblast, it is named as a epiblast. So and this epiblastic cells, so it is future embryo, but this hypoblast cells, they will form yolk sac, what is named as yolk sac. Okay, let's talk about it a little further. Okay, now you see these two processes are going absolutely mutually. Yeah, so and invasion and differentiation of cells. So that's and actually we should talk about this in apart properties. So what happens with the help of syncytial trophoblast? Syncytial trophoblast invade all the space around. So you see it's very small size, and syncytial trophoblast invading it. And here we have blood vessels, we have glands, yeah, and syncytial trophoblast forming the cavities inside its own. So it's known as trophoblast lacuna. So this trophoblast lacuna, so it's a primordium. It's a primordium. It's not a cardiovascular system, but it's a primordium for cardiovascular system in the embryo. So and this and all the blood vessels will be mother's blood vessels will be drained here. You see, blood doesn't touch the embryo itself. It touches only syncytial trophoblast. And that's why I said to you, it's a primordium of the placenta. It's a future placenta, and the first patterns of blood vessel circulation inside the embryo is established right now. And now, finally, embryo has an impact and has a source for the further development. So that's what I said there. An embryo get nourishment, and these cells are growing and multiplying. Okay, so now you see blood vessels implemented into this lacuna cavities, and along with it, you remember these blue cells are named as a epiblast. These yellow cells are named as a hypoblast. And now these hypoblast cells, they starting to form new cells surrounding around, so and they are growing along with the trophoblast, along with the cytotrophoblast. So this hypoblastic cells surround hypoblast, and now it forms the cavity, which is named as a yolk sac cavity. So it is so actually in placenta animals, so the function of this yolk sac actually not very important. Yeah, we understand that this yolk sac is not providing feeding. So one second. Okay, sorry. So and they form yolk sac. In the birds, it playing not only in birds and reptiles, it's playing a very important role because it is a container of nutrients for the further development of embryo. But in placenta animals, who humans are, so we are placenta, and we don't need it. But still, embryonic roles, embryonic fashion, so we're so by myriads of days, by plenty of years, it was established. Yeah, so by established the same pattern. So that's why we can just remove it, yeah, from the from our embryonic period. So, but actually, we can imagine the situation when yolk sac will be not necessary, but we have what we have. Yeah, that's how evolution works. So that's if evolution made the yolk sac, so might be yolk sac is required. So now all the fashion of the development is based with the yolk sac formation. Okay, and in other side we have a formation of the amniotic cells. So this epiblast from other side of the embryo, it forms the amnion cells, and between and you see what happening. So and here we have a cavity which is named yolk sac cavity, and from this side we have an amniotic cavity. Okay, just going furtherly, I have to say to you that this amniotic cavity is a future that cavity which will surround entire baby before the birth. So maybe you remember, you know, this amniotic fluid, yeah. So which is which is excreted during the delivery. So this
That's
is
right.
it started here. Sorry. Okay. So this is amniotic fluid which is surround the entire baby, but we don't remember what is the yolk sac, yeah. So after the birth, so that's we going to discuss a little later what happened to this. Okay, that's it about the lecture part. So now I'll show you a few videos, so just keep it in mind. Алло, да? Подошли? Да, подошли? Да, сейчас буквально 5 минут я закончу и вас приму, хорошо? Да. Okay, that's videos I shown, so I will settle it, also send it to you, so in Google Drive, so then you can observe it there. Okay, thank you for attention. So if you have any questions, you're free to ask. If you have no more questions, so thank you. Goodbye.
Thank you, sir.